Hello everyone, welcome to this webinar. Today we're going to go through the new features of IDEA StatiCa version 22.1, and yeah, we're going through all the new features both in steel, concrete, and BIM links. So I'm the presenter today. My name is Fredrik Andresen. I'm a technical support engineer here at IDEA Medeso. I do support for IDEA StatiCa and the CSI products. We are using the platform GoToWebinar, so you are muted by default, but you can, of course, post your questions, and we will go through them at the end in the Q&A. So the agenda for today is first go through the highlights and then go into detail of what is new in steel and concrete and BIM links, as mentioned. So in the highlights there is a new analysis and code check for fire resistance. We also have now horizontal tying resistance. It's for mostly customers in UK. That's a brand new analysis and code check also. We also have a new weld and contact for edges under compression. Before you had to choose between welds or contacts. Now you can choose weld and contacts. In concrete, pre-stressing in detail. You can now do serviceability limit state checks of pre-stressed beams or details in the application detail. There's also some mesh improvements in detail. And you can also do thermal analysis in member. And for BIM links, there are user experience improvements for checkbots. Lots of small improvements to make the user experience better. There's also better geometry recognition when you import from CAD or FEA software. It's much better now. There's also some improved stability and debugging in the BIM API for those of you that uses that. So let's go into the details and look at what's new in steel first. As mentioned, there's fire resistance analysis and code check, horizontal tying resistance, weld and contact, and we also have a new plate and weld clash check that will give you a message if something is wrong. And then dialogue is a little bit redesigned to look better and to be more streamlined. There's also for gusset plates, there's improved cut when you have notched members. There's also another new cut that allows for cut of member plate with more than 4 edges. And timber connections now show angle of grain, angle 2 grains also. So let's go look at the new analysis called fire resistance. It's under all the codes and national standards. So, and of course, Eurocode. You input the material temperature, and yeah, for connection, there's temperature for each member and plate, and for bolts and welds, the temperature are taken from the plates. And in the application member, one temperature is for the whole section. So let's show a little demo. So here in SIA, we have a global model with some low combinations for fire also, and fire temperature curves. And after the analysis, we're interested in the material temperature, which we can then put into IDEA. Here we also have the material temperature curves. So we choose a connection, import it to Checkbot, and here we can review the load combinations. There are some regular load combinations and also for fire. And we choose a connection suitable for the beams and members. And now we just run the analysis for the normal load combinations and switch over to the fire analysis and only check the fire combinations, input the temperature, choose the correct members and items. And now we can calculate and go to report. And here we can see the results from the thermal analysis and see the temperature and the response for plates and welds and so on. So next thing is horizontal tying resistance. It's as far as I know, only a requirement in UK, but it's great to have for the rest of us. So you choose one member to be analyzed, and you put on the tensile force, and it's it's a different material diagram factors and code checks if this is chosen to, if you choose to run the horizontal tying resistance analysis. So we have a little demo here. We have a connection which passes the code check, and we choose horizontal tying analysis. We choose which member is to be set analyzed. Input the normal force on that member. Go to check, and here we can see the response. And yeah, the factors and material factors are changed, and we can see the response in the results. The next thing is weld and contact on same edge. So this is for customers who have machined edges and where it's no gap. Then it's great to have this weld and contact on same edge, because now the weld is utilized first, and then contacts take compression after that. So, but this is also for compression only contact, for typical for columns, footings, and so on. Plate and weld clash check. Now we get a warning if there is a clash between plates or welds. So that makes the user experience much better. It's on by default since this update with the 22.1. So you get immediate information during modeling these messages here. So you save time by knowing if there is a clash, and you don't have to go looking for where is the error in my model and so on. So yeah, you can save time, and it's more user comfort. There is also some redesign in the dialog. So yeah, there is a unified look of all the windows and apps. So it's supposed to look the same, and yeah. There's also some hotkeys activated. You can now press enter to confirm and escape to close the dialog or hit no. And yeah, some more will come later also. So to sum it up, now you can be more safe with fire design and horizontal tying. And it's improved visual control. It should improve the efficiency of modeling here. And yeah, it's a better user interface also. So going over to the concrete. I will mention the highlights for you that we have done in version 22.1. The complete code check of prestressed detail due to implementation of serviceability limit state. And there's a new measure behind the detail app. Also, advanced design and code check of existing and new structure using thermal analysis, and many more improvements, which will be mentioned in the upcoming part here. So pre-stressing in detail. Until this time, the code check of cracks, deformation, and stress limitations for prestressed discontinuity regions. It was a huge problem that engineer had not solved, or the solution was very complicated. So now that the complete code check of prestressed discontinuity region, it's out. So that's very good. Right now, you can design and code check, for example, whole pre-stressed beam with openings in detail. So the important code check is the decompression, where the tendon has to be in compression area of the concrete. Otherwise, the corrosion and other factors can influence the lifetime of the structure. Also, the linear model can appear big peaks of the stresses, which gives the non-real value and affect the code check of stress limitation in the concrete. For example, under anchors. Yeah, also pre-stressing in detail. Yeah, also for bridges, a typical example of problematic regions where engineers were not able to detect the cracks and nonlinear deformation. Right now, the solution is out, and it's feasible and very easy to use. Yeah, the mesh is essentially essential for every FEA application. The number of elements, type of the elements, and quality itself leads to some level of discretization issue compared to continuous solutions. So in IDEA StatiCa detail, a new adaptive measure has been implemented that adapts the mesh according to the shape of the discontinuity and optimizes the number of elements, so that at least 4 elements describe the stress on the smallest edge. That leads to increasing number of elements in the parts where the singularity area appears, for instance, openings and supports. And that will lead to reduction of the elements number in the other area. So it's more efficient. On the other hand, the measure removes the triangular elements and replaces them with quad elements, which describe the stress state for the same number of elements more accurately and calculation procedure is now faster. There's also now thermal analysis in the member application. So yeah, a material such as concrete changes its physical properties when exposed to fire, and finding out the temperature describes description. The distribution across the cross section, and reducing the properties of concrete and steel is a difficult task that most engineers solve with simplified methods that are very conservative or even fail to solve these problems. So that's why we're glad that this terminal analysis is out. Limits have been broken in the design and code check of concrete structures exposed to fire. The analysis is valid for beams, columns, and frames in this member application. This is a non-stationary heat transfer where nonlinear material diagrams are also used together with material degradation according to the temperature field in the cross section. So the process, I will also show a demo, is that you create the geometry. You also input the boundary and initial conditions. Then you run the thermal analysis, the material nonlinear analysis. Then you run the geometric and material nonlinear analysis, and then you can go to report and review the results. Yeah, there's also a simplified method for shear and torsion. So with the new solution, there's no more estimation and code equation for redistribution of the internal forces and reduction of the stiffness. You can now design and code check these beams and frames using geometric and material nonlinear analysis and get proper redistribution. So also improvements for hunches and rebar adaptation. Yeah, you can perform the linear and non-linear analysis here also. The user get extension and design and code check options for new and existing structures. So we'll now go through and look at this, an example of a beam. So this is a T-beam cross-section where we now have, we'll look at the pre-stressing. So we have 3 load combinations, permanent, variable, and pre-stressing. We also put up ULS and SLS checks. We can go through the factors for nonlinear load combinations. And we also have to, we can also see that we have now pre-stressed tendons. You can also put in post-tension tendons also in this detail application. So you input your data, number of strands in layer and so on, and the beginning position, end position. So in the bottom layer there, we had some pre-stressed tendons, and we also have some post-tension tendons in the same beam. Here you can see the visual representation of how it looks, and also the input data, pre-stressing procedure, how it will be anchored and how it will be pre-stressed. So we can go into the check and see the code setup. This is the new section where the stress limitation can be inputted. So we do the analysis and we can review the results. First we look at here stresses from the tendons. We can look at it long term, short term, and look at the maximum stress in the concrete and in the tendons and so on. So you can, we also can put in the creep coefficients and look at the cracks, which is very important. And you can get all sorts of results, all the required results from the Eurocode rating. And all of this you can also get in the report, of course. So here we can see the decompression check, also the deflection from the pre-stressing. And of course, we can also have all the results in the report. And you can have it standard report with kind of a normal detail grade, or you can also have absolutely everything, all the results, all the code checks in the report, like always. Also, I will go through the short demo on the thermal analysis in Member. So here we have we will create a concrete frame, or we will look at a beam now, but it's in the frame, so to say. And we'll put in the resistance class and choose the length of the beam and the cross section. And we have some load combination here. So we have to, we choose ultimate limit state and input a load, and then we go into the fire resistance, and now we can then reinforce the section. We have to have some reinforcement. So now we add the fire exposure and choose the whole cross section. And we can also choose the edges that is supposed to be exposed to fire. So we can go into the check and run the geometric and material nonlinear analysis. First, you have to go into the fire design and review the fire resistant class, fire curve, and so on. And you can also go in and change the parameters in the code setup, how you want it. So we calculate it. And results, you can see that. You can go into the temperature to review the results now. We can go into detailed and check all the cuts along the beam. We can see the temperature in each section of the beam and go through the results in detail to review it. So now we will look at buckling results and go through all the geometric and material nonlinear analysis with the imperfections, and also look at the results there. We can also choose another load combination to review the results. And the internal forces, We can also switch on the normal force to see the effect of the thermal load. And yeah. Here again, we can see the sections. And after that, we can create the report, and we will get the fire results in the report also. Here we have fire design in the report, which is new with this version of IDEA StatiCa. So this is how it looks. So to sum it up, for the new improvements of the concrete, we now have a complete code check of pre-stressed details in general, new meshing, and yeah, it results in more accurate results and faster solutions. So you will save time and material, hopefully. And also with this using thermal analysis is included in the software. Over to the BIM links. There are improvements in the user experience for Checkbot. There's also been some better stability and debugging possibilities in the BIM API. Also better geometry recognition when you import from CAD or FEA software to the checkbots. And also some IOM improvements for if you use some of the development tools. There's also a there's also a webinar on that IOM, so not going to go through that in detail. So the improvements for Checkbot, you can now choose bulk selection of connection items in the Checkbot. Before you can only choose one, but now you can choose more than one. Also, right mouse button is available. Yeah, and there's also better integration of the Bentley STAD Pro software. So that you can also, yeah, we'll go through a short demo here. Now you can, as you see, choose more than one connection at a time in Checkbot. You can edit it or delete or whatever. So now we will choose these four bottoms of the columns, and now it's the possibility to export more than one connection, and you can now send those to your colleague, for instance, and you can edit it or yeah, whatever, or finish them. So yeah, as mentioned, better stability and messaging for the BIM API. Yeah, not going to go through this in detail. There's a separate webinar from IDEA StatiCa on this topic. Better geometry recognition. So yeah, the cross sections is rotated in the correct manner, which could be a problem before. So now it's much better. It's transferred correctly now. These are the current BIM links in version 22.1. You can also find this on the website. Another thing, FEM design is not on this list, but it's being developed. So yeah, hopefully by the end of this year or the start of next year, it will be out. A bonus feature is the search bar in the top right corner of the software. Here you can search for whatever you like, and it will direct you to the articles in support center. So maybe that will yeah, lead to fewer support questions, and
you users can be able to find what you're looking for much easier. So hopefully that is yeah, better. Then I think we'll wrap it up and yeah, say thank you for today. So have a great day.